Hey everyone, and welcome to this explainer. Today, we're exploring a totally radical shift in how we understand and, well, interact with our own planet. For centuries, uncovering the Earth's hidden resources has been this massive game of physical grit, giant machinery, and honestly, a whole lot of guesswork. But we are officially leaving that era in the dust. We're transitioning from that traditional boots-on-the-ground physical exploration to something that sounds like it was ripped straight out of a science fiction novel. We're talking about space-based algorithms discovering the resources of tomorrow. Okay, let's dive into this. I want you to imagine this scenario. What if an algorithm could find a billion-dollar mineral deposit hidden kilometers underground without a single geologist ever setting foot on site? Sounds completely impossible, right? Like, how could a computer program just sitting in a server room somewhere find something buried under layers of rock, dirt, and history without anyone actually picking up a shovel? Well, here's the crazy part. That exact scenario isn't some hypothetical future. It's exactly what is happening right now, today. To truly wrap our heads around why this is such a massive revolution, we have to look at the sheer friction of traditional mining. Historically, less than 1 in 1,000 exploration targets actually becomes a functioning mine. 1 in 1,000. Imagine trying to run a business or, transition the entire global economy to new energy sources when your foundation has a failure rate of 99.9%. The reality is that traditional exploration is incredibly difficult, highly uncertain, and packed with massive, massive friction. Now, what's really interesting about this comparison is the sheer scale of the upgrade. The old way of doing things meant literal decades of work and hundreds of millions of dollars just to see if a site was even viable. It was slow, incredibly expensive, and as we just established, it almost always ended in failure. Contrast that with what AI exploration brings to the table. Instead of decades of physical labor, we're relying on algorithmic precision to find invisible patterns. We are quite literally trading physical guesswork for digital certainty. So how does AI actually pull this off? Well, it all comes down to highly educated machine learning models. These algorithms aren't just making wild guesses out of nowhere. They're trained on decades of geological data. They relentlessly analyze massive geochemical records, and they integrate historical satellite data that's been collected over years and years. By combining all these massive, totally disparate data sets together, the AI finds patterns that are completely invisible to the human eye. I mean, no matter how experienced a geologist is, they literally cannot process millions of data points simultaneously to see these hidden connections. But the AI does. And because of that, it predicts exactly where valuable deposits are likely to exist right beneath the Earth's surface. Let's move to and see how this builds into an actual actionable process. First, the whole thing starts in orbit. Satellites detect these unique light signatures from space using hyperspectral sensors. Next, those satellites beam this massive, overwhelming amount of data right back down to Earth, where the AI processes it all in mere hours. And finally, the algorithms generate highly accurate mineral maps based on that processed data. This is a seamless workflow that entirely bypasses what used to be literally years of manual surveying. And this brilliantly illustrates the secret behind that crucial first step in orbit, the hyperspectral sensor. These are specialized instruments capable of detecting the unique light signatures of specific minerals, right from space. Think of it kind of like this. Every single mineral reflects light in a very specific, unique way, almost like a chemical fingerprint. These sensors are the ultimate eyes in the sky. They can look down at the surface of the Earth and literally see the chemical composition of the ground just based on how the light bounces off of it. That is how they gather the incredibly precise data the AI needs to make its groundbreaking discoveries. To see what this actually looks like in the real world, we can look at companies putting this into practice right now. Take KoBold Metals, for example. They're targeting incredibly crucial resources for modern technology and batteries, stuff like lithium and cobalt. And they are actively using this exact AI-driven approach to make discoveries in places like Zambia and Canada as we speak. So this isn't just some pilot program in a lab somewhere. This is a highly active global operation that is completely reshaping how we source critical materials. So the crucial point is the dramatic compression of time we're seeing here. AI processes this mountain of data in hours, generating mineral maps that once took human teams years to produce. We've gone from a timeline measured in decades down to a timeline measured in hours. When you can compress years of painstaking, massively expensive mapping into just a single afternoon of algorithmic processing, you completely disrupt the economics and the speed of global supply chains. It's a total game changer. Ultimately, it all boils down to one absolutely powerful realization. The next major copper or lithium discovery won't be made with a hammer. It'll be made by an algorithm. The hammer represents the old world, right? Hundreds of millions of dollars, decades of time, and a brutal 1 in 1,000 chance of success. The algorithm represents the new world, orbiting sensors, invisible pattern recognition, and incredible digital precision. We are trading physical labor for digital intelligence to secure the future of our planet's resources, and it is fascinating to watch. This technology is moving so fast, and it is actively reshaping our planet and our technological future right before our eyes. It really makes you wonder what they're going to point these satellites at next. So, I want to leave you with a question to consider today. Which mineral do you think will be the absolute most critical in 10 years? Will it be lithium, cobalt, copper, or maybe something we aren't even thinking about yet? Whatever it is, an algorithm will probably be the one to find it. Thanks so much for joining me on this explainer, and I'll catch you next time.